Hey there, welcome to Beals School, the educational side of my other YouTube channel, which is Beals Science. Today we're going to learn about the periodic table. Really, this part's just going to be a general overview of the periodic table and all the bits and pieces you need to know. It is the first in a whole series of videos to teach you about the periodic table, because that's what I do for my day job. I teach science at high school. So the periodic table is governed by something called periodic law. There is a periodic repetition of chemical and physical properties of the elements when they're arranged by increasing atomic number. That's what gives the periodic table its unique shape, but also makes it so useful, because the location of everything on the periodic table helps us understand how it acts and what it's like. I'm going to encourage you to go ahead and download this free blank periodic table, because if you're learning about the periodic table for the first time, the best way to do it is to write things down right along with me, not to just pull up a periodic table and look at it. So I'll put a link right down there in the description so you can print one of these off and follow along. First thing we need to understand are something called groups and periods. It's how the table is arranged. So moving down this direction in what we would call a column, that's actually called a group. And when we go across this direction, that's called a period. Now, the reason we have groups, the reason the elements are stacked on top of each other, is that because they have similar valence electrons. Remember, valence electrons are how many electrons are in the outermost energy level or the outermost shell of an element. So they're grouped together according to valence electrons. And that means they have similar properties. So like maybe they're highly reactive, or maybe they're not reactive at all. And we'll get into those things throughout the course of these videos. This direction, horizontal, those are called the periods, all right? The period similarities tell us that everything along that period right there has the same number of energy shells. In other words, its outermost electrons live in the same energy level for every one of them in those periods. We're going to walk you through that step by step, and we're going to fill out our blank periodic table to be able to do this. So let's start off with the groups. We said that they have similar electrons or similar valence electrons, and they have similar properties. So the first thing I'm going to add to my blank periodic table are the group numbers. These are the group reference numbers. So that first one there, that's called group 1. That's pretty easy. Next to it, we have group 2. Then we have group 3. Wait for it. Group 4 and 5 and all the way to 18. So we have 18 groups. Those are our reference number groups. And oftentimes people find these useful because you can say group 18 and you can find it immediately. But to me, it doesn't tell us a whole lot about the periodic table. I think there's more that we need to know. Now, the periodic table is broken up into many groups, including those vertical groups that we're talking about. But there's something called the main group elements, which are the representative elements. And I like to tell my students that they're called the representative elements because they follow the rules for electron filling order really well. All right? They represent them well. And I think that's the easiest way to distinguish them between the ones we're going to talk about next. I think there's a useful way, or a far more useful way, to categorize our periodic table. And that's by putting this Roman numeral 1 with the letter A. The A represents, right over here, representative elements, okay? And the 1, the Roman numeral 1, now that tells us how many valence electrons everything in that group is going to have. They're all going to have one valence electron. To me, that's helpful. This one's going to be group 2A. Now, we have to jump over what I like to call the Grand Canyon of chaos here. These are the transition elements. They don't follow the same rules. We're going to come back to those. Instead, we're going to jump right over here, and this is going to be our 3A. This group is 4A. This is 5A, 6A, 7A, and 8A. Roman numerals. Aren't they beautiful? Too bad my handwriting isn't. So what this 3 means, there are 3 valence electrons in that group, 4 in that group, 5 in that group, 6 in that group, 7 in that group, and 8 in that group, except for this one. And we'll get to those exceptions here coming up. All right, the transition elements have something kind of goofy going on. They have partially filled D subshells, and they can give rise to cations with incomplete D subshells. Now, that's a whole lot. If you're just learning about the periodic table, that doesn't make any sense to you. But it will. If you stick with me through these tutorials and through these lessons, eventually all that madness down there is going to make complete sense. Hopefully. But remember, we skipped this. This was the Grand Canyon of Chaos. That's what I like to call it, where things don't follow the rules quite as well as the representative elements up here on the sides of the Grand Canyon or up in the towers of the castle. So this 3 means that those have 3 valence electrons, or should, but there's some weird transition things going on, so we'll have to learn more about that later on. And we're just going to work our way through here, and this is 4B, this is 5B, 6B, 7B, which is VII, and then we have 8B for all 3 of these. So I'm going to put VIII for 8 and then the B. All of those have 8 or should have 8 valence electrons. But again, they have an unfilled D suborbital, and we'll clarify that later on. And we start our counting back over right here to 1B and then finally 2B. Now remember, I did erase these, but up here this went to 3A. And then all the rest of these over here were A, counting our way across. This is a really useful designation, or at least I think it is, because now we understand how many valence electrons each group has. And we know if it's a transition element or if it's a representative element. More on those later. Let's then cover the periods. Now, if you recall at the very beginnings, I told you that the periods go across this direction. So we're going to label them on our blank periodic table. So this is period 1. The one below it is period 2, yeah, very clever. Period 3, period 4, 5, 6, and 7. Now what does that mean? That number tells us the valence electron energy level, which means valence electrons, recall, are the outermost electrons, or the electrons in the highest energy level, which means anything in this period here has valence electrons in the 3rd energy level. Any of them in this period have valence electrons in the 2nd energy level, and all the way through the whole table. So again, understanding the periods is very useful because it teaches us about the valence electrons. Now, we missed something down here. We missed the inner transition elements. They're down here, and they look like they're kind of missing or hiding or something's going on. This is where they should live. That whole section that was just pulled out and down at the bottom back here, see them? They should live right here. But they don't. Now, why don't they? Well, apparently, when chemists got together a long time in IUPAC, which is the International Union for Pure and Applied Chemistry, they decided, well, let's go ahead and take that out of there and move it down to the bottom so that this whole thing can nicely fit on a piece of paper. I mean, that was generally the reason. There's some other benefits to it as well, and we're going to find out that those ones down there have a different electron configuration, so it was totally okay that they were pulled out of there. But I like to think of it as, well, yeah, I mean, they just wanted it to fit nicely on one page so that it would be more useful. So they moved them out. And here they are. Now, if we were going to add on the inner transitions where they belong, remember, this period technically lives right here. And this one technically lives right here. So this would be part of 6, and this would be part of 7, or period 6 and period 7. We're going to give these a name. This is called the lanthanide series, and the one below it is called the actinide series. I'm going to add those to my blank periodic table so that I've got all the information I need to understand the periodic table. Now let's go ahead and designate these. We've got three areas on the periodic table that we need to include. We're going to include the metals, the nonmetals, and the metalloids. Now, I'm going to highly encourage you to use your blank periodic table to color these in. I'm going to use this table to color them in. That way you can clearly see where the lines go and which elements are included. Now, in my class, what we do is we get out the highlighter and we highlight all of these. So I'm just going to outline them. I'll fast forward this a little bit so that you just see it appear. But on your blank periodic table, I would make it nice and neat so that you can do all sorts of learning. So where are the metals? Well, they are right here. The metals. So it's not pretty, but I've pretty well outlined it. Now, there's one more group down here. Remember the lanthanides and actinides that we just talked about on the last one? So now the metals, they're all shiny, they're conductors, they're malleable, which means they're bendable, they're ductile, they can be pulled into strands or into wires. So they're really, really important, really common, and really useful. Now, I'm going to add a few to my periodic table, and one of those is right here, this group. Notice I left hydrogen off of there. Okay, hydrogen's going to belong to something else over here. And we'll talk about why it's over here if it's not a metal. But this group right here has another name. These are the alkali metals. They have a special name because they're highly reactive. And when they react with water, they make alkali substances. The other one are the alkaline earth. So these ones are the alkaline earth metals. On my periodic table, I would write that out all the way, alkaline earth metals. But because my chicken scratch when I'm doing this little lesson up here looks terrible, I've just abbreviated it for you. I apologize, but it is what it is. Those are also reactive, and they react with another group on the periodic table. And so they got a special designation or a special name quite long ago. Then next group we're going to color in are the nonmetals. Now the nonmetals include a lot of the gases, or they're not that metallic color, or again, bad handwriting. I apologize. And our friend, don't forget about hydrogen way over here. These are different than metals because they're poor conductors in general. They might be brittle, and a number of them are gases, so they are not a metal at all. We're going to label two of these. We're going to label the halogens and the noble gases. These are the halogens, this group right here, group 17, and these are the noble gases right here, that group. Sorry about the handwriting. They're called the noble gases because they don't interact with anything else on the periodic table. They don't have to. Remember, we've been talking about those valence electrons, the ones that live on the outside edge. Well, those have a complete outer shell. If they have a complete outer shell, they don't need to mix with anything else on the periodic table. Just like back in the good old days, the nobles didn't mix with the rest of the people. So they got a special name over here called the noble gases. The last one we need to designate are the metalloids. The metalloids actually have properties of both. So this is where we get the term semiconductors, because they sort of conduct heat, they sort of conduct electricity, and because of that, they're very useful because their conductivity can be changed. One that you maybe heard about a whole bunch is silicon, because silicon is what has led to our modern day microprocessors, our computer chips and things like that, because of its properties as a semiconductor. And that's the real general overview of the places, the parts and pieces of where everything lives on the periodic table. Now, we've got a nice colored in blank periodic table, but if you go to the next video in this series, you're going to find out, we're going to start a whole other periodic table and jump into electrons, their configuration, and why the periodic table has the unique shape that it has. So, I'll put the link to the next one right down there in the description, or it'll probably pop up on the screen. But you know what? Keep on learning.